analyze yet. And I tried to understand why in our catalog this star was unclassified, didn't have a surface temperature and gravity. And that led to a lot of analysis and inspection that we didn't have time to do before we published the paper. And so then I had to write up this story to this guy at Discovery Magazine and try and explain this, and I was very worried about it. But I get on the phone with this guy, and they were so excited to see like the scientific method in play. They were so excited that they inspired this additional analysis that I couldn't convince them not to do this feature story on KOI 326. But they did write a very, very nice article that came out, I think just yesterday, or the day before, it was this week, that explains the whole story and the fact that this has been demoted and is no longer considered a habitable planet, a habitable planet candidate, at least not an Earth-size one. It turns out that the brightness of this star in our catalog was absolutely wrong. And it turns out that there's another star right next to it that is much brighter. And the light that we are measuring is the light from that neighboring star. And that star happens to be a little bit bigger. So it's still a bona fide planet candidate, but it's just not habitable and Earth-size. So that's the story. That's the backstory. That's how this is all playing out. Okay, let's see. This is to make you dizzy. Of these 1,235 planet candidates, there are actually 997 stars represented. And that's because 170 of the stars have more than one transit signature associated with them. And so we turned this into an orrery of sorts, these little systems here. This is all real data showing you the sizes and the orbits, the periods, the distances. Not all 170 are represented here. We're only showing you the ones that are close in to their parent star just for display purposes, because you can't show the ones that are really very far. Let's see, and KOI 72, which is Kepler 10, is on here someplace. I can't see it. But there is another one that's very special that I'm going to share with you, because this star showed the flickering of not just one, not two, not three, not four, not five, but 6 transiting planet signatures. And there are 6 planets associated with this star, and this is Kepler 11. Kepler 11, B, C, D, E, F, and G. And they've been confirmed. These are bona fide planets, and we know their masses. What's interesting about this system is that we know their masses from an unusual analysis, which is called transit timing variations. And so what happens is, you've got all these little clocks. You can, just like in the orrery picture you saw before, you've got these periodic events, right? These planets orbiting their stars, and you can think of them as clocks. And here we've got 6 different clocks running at a different rate. The problem is they're not strictly periodic. It turns out that if you try to measure their periods very precisely and predict when the next transit should happen, it doesn't happen there. It'll be a little bit early, and then a little bit earlier still, and then it'll catch up again, and then it'll be a little bit late. And all of them are doing this. And so what's happening is these planets, because they're all so closely packed near their parent star, they are feeling the gravitational tugs of one on the other. And they're exchanging this gravitational energy. And they're doing it in a resonant way. You've got resonances, which means that the orbital period of one planet is exactly, or nearly exactly, twice the orbital period of the inner planet. So it's not just tugging on it, it's tugging on it in a repetitive way, which causes these delays and then these catching ups and then these getting ahead. And so by measuring how much they delay and how much they clock ahead, that gives you a direct measure of the gravitational force between the planets and allows you to derive their masses without the need for any follow-up observations. We did not have to take this to Keck 10-meter telescope. We did. We took some observations, but just to make sure, just as a sanity check, because this had only been done once before, also by Kepler a couple months earlier on Kepler 9. But Anyway, 6 planets all orbiting the same star. This is what it looks like compared to our solar system. 5 of the 6 are all within Mercury's orbit. 1 is out here between Mercury and Venus. 6 planets packed closely into their parent star. And what else? The other thing that's phenomenal about this is, in our own solar system, if you were to pretend you're on another star,